This is 7-6 in Advanced Algebra 2. Today, common logs. The common log is use the word log, and they don't put a number down here. It is normally base what then? Base 10. So you see how they have finally gotten rid of the number down in this situation. There is nothing written there. That means there's really a 10 there. They are asking us to figure out what this is. Well, just think about it for a second. If it was, if we rewrite it exponential, they're saying 10 to what power equals 50. Isn't that what this first problem is basically saying? Is 50 a power of 10? This is going to be nasty, right? Well, on the calculator, there's a button that says log on it. Right here, log. That's your common log. If they're asking you for the log base 50, just punch it in. log of 50, not log base 50, but log of 50, and close the parentheses. It should automatically open the parentheses. Just get in the habit of closing it, okay? And hit equals. That's what we get, right? They ask us to round that to the nearest 10,000th, which is 4 decimal places. So here it is. If you want to go 4 decimal places, 1, 2, 3, 4, cut it off right there. Look to the number to the right of that. Is it 5 or larger? Yes. So that means that this number has to round up. Well, what does 9 round up to? 10. Got to carry the 1, right? And what does that become right there? A 9. That's a 9, and that's a 6 still. So it's about 1.6990. You must have 4 decimal places because they asked us to round it to the nearest 10,000. People are like, but there's a 0 there. That doesn't matter. So about 1.6990. Cool? Let's try this. Is it log base 10? Yes or no? So just punch it in. Log of 120. And round it to 4 decimal places. 1, 2, 3, 4. Cut it off at 4. Right there. And since that's 5 or larger, correct, we've got to round that up to a 2. So about 2.0792. Awesome. Another one. I got it punched in already. I just want you to practice punching it in, but then round it to the nearest decimal place. Nearest 10,000. Sorry. Let's say it right. So about negative 2.5229, correct? Why is that number negative? I thought you couldn't have a negative in this situation. Is this okay? Can this be negative? Because this is what part of it? We know the base is 10. We know this is the argument. What are we really finding? That's the exponent. How come it's negative? Well, tell me about that argument. Is it more than 1 or less than 1? Isn't this like a fraction, so wouldn't you have to do some reciprocating? That's why that's negative. One more. Punch that in. Does it give you an error? Because that is the argument that you're punching in, and that is a negative argument. So undefined, no solutions, whatever you want to put. Okay? Y'all cool with using the log button? Yeah, baby. Now, for the fun stuff. Start out with some easy ones, then get some crazy ones. Is this even a logarithmic equation at all? No, it's an exponential equation. What we've done so far this chapter is try to rewrite them as the same base. You see the guy on the left is base 4. You see the guy on the right is a 19. Do you think you're going to be able to rewrite them as the same base? No. So here's another reason why logarithms were invented, to solve these equations. Here's what we'll do. Let's log both sides. All right, let's do this. I'll do the first one the long way. What do you say we take the log, and we can use whatever base we want. Why don't we use base 10 so we don't have to put a little number down there? Cool. Log of 4x equals log of 19. All I did was do the same thing to both sides, just like you've either added 2 to both sides or you divided both sides by 5. Didn't I just log both sides? Correct? Well, how does that help me? How in the world does that help me? How can this come down? Isn't that a property of one of the logarithms that exponent now moves in front, correct? So this is really x log of 4 equals log of 19. And we'll eventually just start with that. You see an exponent, he comes down in front of the log, right? I just wanted to show you. All I did was log both sides. Well, now you see x is down on the ground where we want him to be. What would you do to solve for x if the x and the log of 4 are being multiplied together? Divide both sides by the log of 4. It says give me the exact solution, so x equals log of 19 divided by log of 4. That is it. There is the exact answer. Before we punch it in, don't punch without me. Any questions on what happened there? I logged both sides. The exponent came in front. And now to solve for x, I just divided both sides by log of 4. Cool? So now let's punch that in. It's about parentheses, right? It's all about parentheses. We need the log of 19. And what do you have to do? Close the parentheses, then divide it by the log of, was it 4? And close the parentheses. And what does that equal? How do they want us to round? 10,000. So 4 decimal places, 1, 2, 3, 4. Look to the fifth guy. Do we need to round up? Yes, we do. So what do we got approximately? So x is approximately 2.1 what? 240. Y'all cool with that? Now we got to check it. And I heard you say, oh no. It's easier than you think to check it because we're going to do it all in our calculator. What was this again? It just goes right back in there, correct? By God, I don't want to type that back in. Do you want to type that back in? So isn't it 4 to that previous answer that we just had, right? That's all we got to check. Let's check it like that. Take 4 to the previous answer. How do you type in previous answer? Second ANS down here, right? You see, I just want to see if 4 to what we got, and just hit equals. What'd you get? 19. Did we do it right? Yep, so then just tell me, check. I will trust that you checked it in your calculator. Does that make sense? It's checked. Next guy. Do you see that the x stuff is up in the exponent? And we will not be able to rewrite this as the same base. 120 is not a power of 5 in any which way. Cool? So let's log both sides. And tell me, let's skip a step, what happens to this exponent when we log both sides? What's it eventually going to do? Come in front. Now here's the thing. It's all about parentheses. That is 4x minus 2 as a quantity. Right? That's the entire exponent. Cool? Put it in parentheses. Now let's log both sides. Log of 5 equals log of 120. Put the exponent in parentheses. Awesome. Okay. Now what? Now what? Now what? Now what? You could divide both sides by log base 5, but then wouldn't you have to like add 2 and then divide by 4? It's going to be a mess. Watch this move, baby. We will now use the distributive property. Isn't log base 5 right outside the parentheses? Distribute log base 5 to this. Wouldn't it be 4x log base 5 minus 2 log base 5? I distributed that. That equals log of 120. 1 second. Is everyone cool with me distributing log of 5 through there? Yes, no, maybe? Okay. Now check it out. All right. What we're trying to do is get x all by itself. Isn't this the term with the x in it? Correct? I need to move him to the other side of the equal sign. Right? So don't I need to add 2 logs of 5 over there? Right? What will be left here is 4x log of 5 equals log of 120 plus 2 logs of 5. Don't let me get too far ahead of you today. Ask questions if you're lost. We cool with that? Yes? No? Maybe? Now here's the weird move for a lot of people. 4 times x times log of 5. This is one term right here, correct? What if it was written like this? Is that the same thing that I just had? Right? It's all just multiplied together, correct? So if I want to get x all by itself, wouldn't I divide both sides by 4 logs of 5? Right? To get x all by itself. So that's what we're going to do. The problem is, you had it written like this. You could still divide by 4 logs of 5. So let's show that so that way we can see what we did when we're looking back at our examples. We're just dividing both sides by 4 logs of 5. And what happens is, the 4's go away and the logs of 5 go away, and all you're left with on the left side is an x. So x equals log of 120 plus 2 logs of 5 all over 4 logs of 5. Don't try to cancel anything out. It's not worth it even if it would cancel out, but nothing does cancel out in this situation. That is the exact answer that we're looking for. Slow down. Typing this in is way harder than you think it is, because how many terms are in the numerator? More than one, right? More than one term in the numerator. To keep it all in the numerator, what do you need to keep it all in the numerator? So I physically write those. Literally put the parentheses around that and put it around this. I think that's a good habit to do anytime. Whatever your numerator is, put parentheses around the whole thing. Whatever your denominator is, put it around the whole thing. And now type what you got. The problem that creates is because this thing automatically starts putting parentheses in every time you hit the log button. And it's like, how many do I need to close this thing up? Right? So let's punch it in. You tell me what it says, because I might not be able to read it. Let me get my calculator up. I'll do this. I'll get rid of you. View. Go. No, that's not what I want. Okay. So first, aren't we typing this in? Correct? Parenthesis. Log. Do you see how it now introduced a new parenthesis for me? Also, of 120. I need to close that particular parenthesis on the argument of 120. Correct? Then what do I got? Plus 2 logs of 5. Don't I need to close the parenthesis on the log of 5? Yep. Now I need to close the parenthesis on the entire numerator also, right? So you have to double them up. Y'all with me on the parentheses? Divided by. You got to put parentheses around this, because otherwise it'll just divide it by 4. You want to divide it by 4 logs of 5. And then don't I need to close that up also? You with me on that? It equals. See if you get what I get. And if you didn't, you missed a parenthesis in there. What is x about to the nearest 4 decimal places, which is 10,000ths? About 1.2437. It'd sure be nice to know if that was right or not. But what can we do to see if that was right? Let's substitute him back in and check him. Don't we want to take 5 to the, more than one thing in the exponent? How are you going to punch it back in? What do you need that exponent to be in? Parentheses, 4 times the previous answer minus 2. Close your parentheses. Isn't that basically what it says? Just realize that that whole exponent has to be in parentheses, and that AS is the fancier way to say x, right? You should get 120 back. Did we get 120 back? So it's just messy, messy, messy. Let's see what the next one holds for us. Let's talk this through. Why can't we call this a type 1 situation? Does every term have a log in it? Nope. Is it logs at every term but one of them? There's no stinking logs at all, correct? It's exponential. Can I rewrite them with the same base? Base 4, base 9, no way I'm getting the same. So our rule is log both sides. And if you log both sides, what happens to those exponents? They come in front in parentheses. In parentheses, they come in front. 3x log of 9 equals 5x plus 2 log of 4. All right, exponent moves in front, then we log. Yes? All right. What we're trying to do is get x all by itself. Do you see that we need to distribute our log of 4 through the parentheses right there, right? Because this has got x's on the right side of the equal sign. This has got x's on the left side of the equal sign. We got to distribute through. So 3x logs of 9 equals 5x. You don't even have to have parentheses around it if it's a monomial. It's just when there's more than one term. Log of 4 plus 2 logs of 4. Distribution. So far, so good. All the x's need to get on one side. It's the same concept of how to solve for x. It's just got all these fancy words in it. Don't you need to get every term with an x in it on one side of the equal sign? Right? So let's subtract this guy over. You have a 3x log of 9 over there in the first place. Now you're moving him over, so minus 5x logs of 4. And that should equal 2 logs of 4. Cool? Now let's stop and think. What do you think about combining these together using a property of logarithm, because that's a subtraction, like combining it together and getting like a division problem out of this? What do you think? I mean, we can do it, right? But will it help us? Because if we do that, where do these x's, the stuff with the x, where do they have to end up going? They got to go back up to the exponent, right? You know, so it's like, I don't want to do the division because that's going to move that crap back upstairs, and I don't want it upstairs, I want it downstairs, right? So, oh my goodness. There's two different terms over here with an x in it. Doesn't that mean that x is like a factor of both of those? Isn't x in every one of those? So can't we factor out an x from each one of those terms? Let's do that. Let's factor out an x. What would be left in this guy if you factored out an x? What would be left? 3 logs of 9 minus 5 logs of 4. Because all we did was say, hey man, I'm going to factor out an x in each one of these terms. And that should equal 2 logs of 4. Cool? Now, it's a piece of cake to solve for x because it's x times this whole group. And we don't care what's in there. How do you get the x all by itself when it's times the whole quantity? Divide both sides by that whole quantity. And you're left with x equals 2 logs of 4 over 3 logs of 9 minus 5 log 4. Woo! Let's refresh real quick what I did. Over here, this was the basics. We rewrote it with logarithms. Exponents came in front. I had a quantity in front of a log, distribute through, get all your terms with an x on one side. That way, you can factor an x out of all of these right here in front, and you'd be left with nothing but numbers. These are all just numbers right here. Nasty numbers, but they are numbers. Then divide both sides by that whole quantity. Now let's punch this in. I think this is a great idea to do before you punch it in. Put parentheses around the numerator and the denominator so you know you definitely have to put parentheses there. So let's punch him in. That would be parentheses 2 logs of 4. Close that up. That was just for the argument. Don't you then have to close that entire numerator up again? Divided by parentheses 3 log of 9, close the argument, minus 5 logs of 4, close the argument, close the denominator. Cool? Hit equals, bam. Negative. That's all right. Remember, these are exponents that we're finding. You can have negative answers. So x is about negative 8.1595. Right? Yes, what I did. What? So, let's check this guy. Problem. Ew! X is on both sides of these guys. First, let's see what 9 to the 3x is. So 9 to the parenthesis 3 times the previous answer. is going to be, right? Isn't my previous answer what I want to put in for x? You must put that in parentheses. Otherwise, it would only take 9 to the third and then take it times x. We want to take it times 9 to the 3 times x power. Let's get this. Yeah, nasty. So let's kind of jot that down. The check is 4.38 times 10 to the negative 24th. Right? Just an approximate. Yes? People. Now, sorry, this happened in class. You might not get the same number I got because this is a really tiny number in scientific notation. Doesn't that mean I need to move this decimal 24 places to the left? This is 0.000000000. Say 23 times in a row, 438. Because your calculator might be a better calculator than mine, it's going to be really nasty. So if yours is different, hold off on it. I'll bet you get the same thing back when you do it again. Sound okay? Right? Your answers should both be the same. My answers should both be the same. But because this number is so stinking small, our calculators might give us different answers. It's basically the number 0 is what we're really getting here. So how do I type this dude in? Like, how can I use the previous answer again since I've already done more work? Here's what we'll do. If you hit second entry, which is the term above the enter, hit second entry, it's the previous entry that we just had, right? Now hit it again. Hit second entry. It takes you back to the previous entry that you just had. And wasn't that nasty logarithm thing that we just punched in our calculator, correct? So I hit second entry twice, hit it. There's that nasty decimal again of that negative 8.15 meow, 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 meow. Cool? So now let's take 4 to the 5 times my previous answer plus 2. I had to get that previous answer by going a couple entries back and hitting enter again. And I'll bet you get the same nasty decimal that you did before. I got my same nasty decimal. Ellie, did you get your same nasty decimal? So regardless of what your nasty decimal is, it should be the same both times because you're using the same calculator. It checks. But folks, I want to tell you this. This check is highly important because think about how scary it is doing this on your own when you don't have the answer key in front of you and you get these nasty numbers. It's like, is it right? I have no stinking idea if it's right. The check will tell you if it's right. Okay? So let's roll on. Let's do that to this bad boy, right? What's our procedure? Log both sides. Go for it. Log both sides. Exponents come in front. Since there's more than one term in the exponent, you want to put them in parentheses. Not an equals, but a log of 2. Cool? Are there x's on both sides of the equal sign? Distribute through the quantities with your logs. So distribute this log of 6 and distribute that log of 2. So that's going to be x log 6 minus 5 log 6. Cool with distribution. Yep. Now, we're good enough solving algebraically that we can do more than one step at once. Let's get all the x's on one side. This has got an x with it, so he starts us off, x log of 6. Then don't we need to subtract this guy over to the other side? So minus 7x log of 2. And then that's all I want on the left side. Doesn't this brother have to come to the right side because he doesn't have an x with it? So I'm going to start with him. I don't care if you put him last or first. It really doesn't matter. But on the right side, those two puppies better be added together. Awesome. Now, the reason why we got all the stuff with the x's on one side is because that is a common factor to each term. So factor x out of each one of those. Because we're trying to solve for x, obviously. Boy, this is real fun. What's our final move here before we start punching stuff in the calculator? Divide by that whole quantity that x is being multiplied to. So x equals 5 log of 6 plus 3 log of 2 all over log of 6 minus 7 log of 2. Do yourself a humongous favor and put parentheses around your numerator and your denominator before you type it in. And I will let you try it and see what you get. So pause the video and we'll see if we get the same thing. The video people. Now before we get going too far, video people, we might not actually get the same number because this, well no, we have to get the same number. This is for x, right? We're not doing the check. We have to get the same number. This is what x equals. So let's get the right number. And did you get negative 3.6069 meow 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 meow. This we have to get the same number because this is what x is. Let's jot them down. X is about negative 3.6070. No, 69. My bad. Yes. So here's my x. First thing I want to do is use it. So I'm going to do 6 to the, do I need parentheses? Yes. X, which is my previous answer, minus 5. Y'all good with that? It equals, this is where we may get a different number, right, because of how powerful our calculator is. I just jotted down 2.006 times 10 to the negative 7th. Check. Boy, that's real clear. What's that say? 2.0. I want to see if that equals. Now, how do I get back to my previous answer? I have to hit second entry. And the problem is that's this entry right here. I would like to get back to the entry right before that. So I hit second entry again, and it will take me back 2 entries ago. Cool? I want this number, right? So hit equals, and it will give me that number back. Now, let's punch it in. 2 to the parentheses 7 times the previous answer plus 3. I better get the same number I had before, and I did. Check. Cool. Woo! Fun, 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 fun. Trust me, you'll do this quite often in the job that you get. How'd you feel about them, though? Right? 4 was enough, don't you think? I mean, it's not like it's hard. It's just they're nasty. And parentheses is the hardest part about it. Change of base formula. This is something you'll really want. All kinds of college algebra questions about change of base formula. So looking through the change of base formula, they say, well, if you want to figure out what this is, why is this different than what we did on the first group of problems? Why can't we just punch this into our calculator? It's now base 10, right? The only thing that your calculator will do is base 10 logarithm. Well, this is a base 3 logarithm. Well, this says the log of the argument divided by the log of the base is what that will be. But you know me. I'm a geometry guy. We prove stuff in geometry. So let me prove to you why this works. It might make perfect sense to you. Y'all cool with me doing that? Rewrite it exponentially for a second. You don't have to rewrite this. Just watch me. What would it be rewritten exponentially? 3 to the x equals 16, correct? Let's see if we solve for x now. Isn't it an exponential situation? First one's base 3, second one's base 16. Can you rewrite it as base 3s? Is that possible? So let's log both sides. Wouldn't it become to x log of 3 equals log of 16, correct? And how would you solve for x? And doesn't x equal log of the argument over log of the base? Isn't that a situation? Right? Isn't that what happens? So that's what this happens every single time. If we've made you rewrite it exponentially, then log both sides. It's always the log of the argument divided by the log of the base. So let's punch that in. Cancel. I want an eraser is what I want. Let's punch it in. Let me get to my calculator screen. I want log of what divided by log of what? Log of 16 divided by log of 3. And you tell me, is this going to give me the right answer? Let me make it big for you. Is that going to give me the right answer? Nope. What did I forget to do? So log of 16 closed divided by log of 3 closed. Boom. About 2 point, what does it say to round to? 10,000. So about 2 point what? Tell me. 5237. What do I need in front of it? Approximate. Try this bad boy. Log base 200 divided by log base 12. I keep saying base. It's not base. Log of 200 divided by log of 12. Sorry for my stupidity. About what? Sorry, and I wanted you to write this down. So on the homework, let's do the next one the way we'll do it on the homework. I want an exact answer, and I want an approximate answer. So see how I wrote this? Let's do that on the next one. Exact answer is log of 5 to the 4th. If you want to punch that in first, you can. What is 5 to the 4th power? So log of 625 over log of 6. That's what I want you to have. And then tell me what that is approximately. It's about 3.5930. Nice. Yes, sir, Bob? And then the next one. Log of the argument. I'm going to write it as 39 to the 1/3 over log of the base, log 4. Cool? If you are a person who really wants to put that in front, you can. You just got to type it in correctly. I'm not going to put it in front. I'm just going to type what I see. But here's the problem. Isn't the entire argument this? Right? That has to go in parentheses. So punch it in and see what you get. I hope you get 0.8809. 0.8809. Let's see. Log of, what is it, 39? Let me get rid of this. Go away. Go away. Log of 39 to the 1 divided by 3 power divided by log of 4. Look at all the parentheses I had up top. Let me make it a larger view for you now. I said, yo, man, I want to say, here's my entire argument up top. Then I took 39, which 39 doesn't actually have to be in parentheses, but I did put it in parentheses. Raised it to the 1/3. I should switch colors in parentheses. Like, did we get it, is what I'm asking you. Cool. I'll have to help you, okay? Next. Read. Use this formula, pH. You've had a science class where you talk about pH, right? pH equals negative log of H plus, where I don't know if that's your positive hydrogen. I have absolutely no idea, you know? But, oh, it's the concentration of hydrogen ions, okay? Tells us. Round to the nearest, what? 10th, because that's how pH rolls. pH is rounded to the nearest 10th. Cool? So, here's the formula, right? First, let's start with our very first problem by writing that formula down. Please use the appropriate letters how they are. The P is lowercase, the H is capital. And they call that variable H plus. Cool? What do we know in part A? There are only two variables, pH and H plus. What do we know? So let's figure out what the pH is. It is negative log of, I'm going to change this number into a decimal. It's all going to be in scientific notation. This means move the decimal this many places to the correct direction. If that's a negative, which direction would you move the decimal, left or right? And if that was a positive, you would move it to the right. Let's move the decimal one place to the left. What are we putting in there? 0.1. Awesome. Question for you. What's the base of this particular logarithm? Base 10 is pH all by itself on one side of the equal sign. Punch this in your calculator. Negative log of 0.1. Negative log of 0.1. Boy, why would this come out so nice? How come that came out so nice? Well, let's just see. It's negative log base what? Of 1/10. Can this number be rewritten base 10? What is 10 to what power is 1/10, my friends? To the negative first. So you have negative 1. What's negative 1? It's 1. So the pH of that particular dude, this one was exact. It equaled 1. Cool? Let's do tomato juice. I don't need to write the formula down again. We understand it. It's the same problem over and over and over again. It's the pH equals negative log of, put that in decimal form though. How many places do you move the decimal? 5. So how many zeros will be in front of it? 4 zeros. 794. This one is going to come out nasty because the argument is not a power of 10. So just type in negative log of that and hit equals, and you've got to round it, so it's going to be approximate. What did you get? 4.1? Is that right? 2 more. Get those 2 done for me. Change this H plus to a decimal for me. And hopefully this is what you got. The pH of blood is about 7.4. The pH of toothpaste is about 9.9. Yep. Uno mas. Read it. Substitute in. They give you a formula and a bunch of words. Substitute in. How loud this is in logarithmic scale also. There's the formula that measures the decibels. So the loudness in decibels is by this formula. M is the minimum intensity detectable by the human ear. I is the intensity of the sound. Residents living several miles from a concert venue can hear the music at this many decibels. What does this number go in for? So I like to put an L above that personally. It's not the most complicated thing in the world. How many times the minimum intensity of sound is detectable over the human ear was the sound? If M equals 1, well, they straight up tell you M is 1. So there's only one thing you don't know, which is I, correct? 66.6 equals 10 log I over 1. Do you want to write I over 1? I'm just going to write it as I. Talk me through it. What would we do? We have 4 scenarios of how we've solved an equation this chapter. Sometimes we could write them with the same base. Sometimes you can't write them with the same base. Sometimes there's a log in every term, and sometimes there's a log in every term but 1. What scenario are we in right here? There are logs involved, correct? So it's none of that same base, all that other stuff. This has a log, that does not have a log, correct? So it's a log in every term but 1. Get the log all by himself on one side of the equal sign. Get the log all by himself on one side of the equal sign. Get the log all by himself. You could bring the 10 up, but that would cause you more problems than good. You know, like people are like, can you just take that 10 and put it up here? You could. Why don't you just divide both sides by 10 instead, right? So what's 66.6 divided by 10? That equals log of I. And now what do you do when you've got all the logs on one side and all the constants on the other side? How do we solve these equations? Do the logs just disappear? No, because they're not in every term. But we'd like to make the log disappear. I want to get rid of it from logarithmic form and put it in exponential form. So what's the base? 10 to the 6.66 equals I. To the 6.66 equaled I. How would you round that? We're talking about the intensity. Like, what do you feel we should round that to? I would say to the nearest whole number, personally. It doesn't tell you how to round, you know, but it's an about, right? About. So I is about 4570882, comma, comma. What's that mean? What's I stand for? Intensity of what? Because M is also about intensity. The intensity of sound. So, what does the 4 million something or other mean? That the sound that these people heard, right? Didn't these people hear some sound, right? It's what? 4 million blah, 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 blah times as intense than the human ear normally hears. So let's write this. The sound is about that number times as intense than what is detectable by the human ear.